Alright kids, here's my last video of extra practice examples from section 10.4, last section of AP Calc AB for the year 2020. I picked out a few problems, just 3 because there's only 10 to begin with, from your practice problems that have a little bit of extra, stuff going on. So, number 4 is the first one that I chose, and number 4, you have an x, cosine of x squared. And remember, these are going backwards. You're trying to figure out what the actual equation would be, what the y equals function would have been that has this particular derivative or slope. So as I looked at this one, it didn't look too bad because see how all the x's are over here? I'm going to move Mr. X over there, the dx, by multiplying. That gives me this, dy equals x cosine of x squared dx. And so the setup for separation of variables, that's a pretty funky looking x, right? The setup for separation of variables, that doesn't look so bad. So let me now integrate, or think about integrating. And here's what I've got. So on the left, the integral of a dy is a y. And you're like, woohoo, y equals. But when you get to the right-hand side, you're like, oh no, that is a multiplied thing. I have to figure out how to take the integral of that. And guess what it goes back to? Yep, separation of variables. I think that was section 10.2. So we're going to have to treat this like a separation of variables where we do, where we do the u substitution. So I've got to pick a u. And if I'm looking at this whole thing, I think you remember you picked the worst part, which is just the x squared. In this case, remember you're trying to do a substitution. If you took the whole cosine of x squared as your u, then you'd need to take the derivative of that, and you'd have a sign involved, and you don't see any sign in your original function. So you're not going to take the trig function with it, you're just taking the angle. Let's see how it works. U is x squared, that makes du a 2x dx. And I'm like, oh cool, I got an x. Here, look, I have an x, I have a dx, I don't have a 2. So swing the 2 to the other side. 1/2 du is your x dx. And then you can make the substitution that you need to make. Now I'm still going to keep this integral sign here for now. So I have the cosine of u, and I have the x dx is equivalent to a 1/2 du. And so we know that the 1/2 can come out in front. That's going to give me the integral of the cosine of u du. And so if I'm working my way backwards, I know that this one is going to be the integral of cosine is sine. So this is going to be 1/2 the sine of u. I do not have bounds, so plus c. And we know what u is. U is x squared. So my final equation is y equals 1/2 the sine of x squared plus c. And so that one involved a little bit of your u substitution stuff that you learned back in section 10.2. So I thought that one might be kind of interesting for you to look at. Number 5 is the next one that I thought was kind of interesting as well. It gets a little bit funky with exponents and such. So let's see if we can decipher this guy. And also this one gives us now an initial condition, so I can actually figure out what the c value is. Number 4 did not give me that information, so I just left it with the plus c. All right, separate the variables. X is on one side, y is on the other. That's going to look like this. If I take the dy, actually if I take this y and bring it over here, I have to divide by it. So this is going to give me dy over y. This one, if I multiply by the dx, it gives me on the right hand side a sine of x dx. All right, so I'm trying to integrate it, set it up to integrate anyway. And so I'm going to have this be a 1 over y dy equals the sine of x dx. And so I'm ready to take the integral of those things. Here's where I go, integrate, integrate. Well, 1 over y is an ln. So this is the ln of y on the left. I'm not going to put the plus c with that because it's got the ln involved. I'll toss the plus c on the right. And if I take the integral of sine, it's negative cosine. And then I don't have any anything on my angle that I need to divide by. So I'm just going to put my plus c over here. Now at this point, eventually we want to solve for y. We want what the actual function would be. But at this point, it's easiest to figure out what the c value is. So that's what I'm going to do. If x is 0, y is 2. So this is the ln of 2. equals the negative cosine of 0 plus c, and from that information I'll be able to figure out what c actually is. All right, well, the ln of 2 is just the ln of 2. We're going to keep this as a non-calculator. Cosine is 0, so go around your unit circle. Oh, I know you love him so much. And if you think about the unit circle, what coordinate goes at 0? That would be the coordinate 1, 0. So I'm thinking coordinate-wise what that might be. Cosine is the x value, so that makes this a negative 1 plus c. And so I can solve for c. C equals, swing the 1 over, the ln of 2 plus 1. Now again, I'm going to keep that as my ln of 2, not put it into a decimal form. So here's where I'm at. I'm going back to my equation, which was here. I'm going to go into 6's territory. ln of y equals the negative cosine of x, and then plus c. Well, c is ln of 2 plus 1. And my job is to figure out what y equals, but y is tangled up with this natural log, and it doesn't want that there. You want just the y. So I've got to use my rules for logarithms and exponents. And remember, there's an invisible base of e down here, and I'm going to do my loop-de-loop and see if I can figure out what y is. So it's going to be e to the, guess what? This whole hot mess over here, that's your whole power. Cosine of x plus the ln of 2 plus 1 equals y. And that's your answer. Y equals, you got it in a y equals format, but it just happens to have a really big exponent this time around, and you say, okay, so what? It's a big exponent. All right, that's number 5, and the last one I want to do with you is number 10. And number 10, same idea. I got a little trick going on with this one, though, because see how the x's and y's I kind of can't just easily cross multiply or something like that. I somehow need to undo this exponent. And if you remember with exponents, when you're adding them, it's like multiplying, but when you're subtracting, it's like dividing. So really this is equivalent to dy over dx on the left, e to the x divided by minus e to the y. And if you can remember that little rule from exponents, that makes this problem way easier. Because now if I cross multiply, look at what I'll have. I'll have e to the y dy equals e to the x dx. And I'm like, woohoo, I separated the variables. That's awesome. So I'm ready to integrate, and that's what I'm going to do. I'm going to take and integrate on the left, integrate on the right. Well, lucky for us, when I integrate an e to anything, it's that same thing. So this is e to the y equals e to the x. Somebody's got to have the plus c. Might as well put them over here. Now ultimately I'm going to solve for y in this equation, but I'm not quite there yet because I have actually, if I read through, they want us to not only sketch the particular solution, which we'll do in just a second, they want us to find the particular solution, and they gave us a fact, they gave us an initial condition that when x is 0, y is 2. And so if I plug that into this to see what c is, it's going to be e squared, my y is 2, equals e to the 0 plus c. And we know anything to the 0 power is 1, so this stays e squared equals 1 plus c. And so c is equal to e squared minus 1. And so let's go back to our equation here. I have e to the y equals e to the x plus e to the second minus 1. My c is x squared minus 1. Now check this whole thing out. Remember, I want to get it into a y equals? Well, that's kind of not there. I've got all these e's that are in my way. And so the only way I can undo an exponent like that is to bring back logarithms. Remember, they're vice versa, they're inverses of each other. And so what I'm going to do is I'm going to ln this side, and I'm going to ln this side. Now if I take the ln of e to the y, ln's and e's undo each other, and I'm left with just a y equals. And y equals, I can leave this, the ln of e to the x plus e squared minus 1. And so really you just needed to ln the left-hand side to get rid of that, so you just get the y equals that you wanted, and you can leave this as the ln of e to the x plus e squared minus 1. So there's your particular solution for part B. But then they say to you, okay, well now part A, sketch a particular solution through the point 0, 2. So 0, 2 would be right here. plot the point, and then stay in the cattle chute. Right? Follow your slope fields. Looks kind of like that. And that, my friends, is your answer to number 10. So, you are now able to do the rest of the problems from 1 through 9 that we did not do. And I hope you're doing well. You can email me with any questions, and I miss you, and I'll talk to you soon. Bye.